Hello. Hello, everybody. Good afternoon. My name is Dawid Ostrowski, and I'm a program manager in the developer relations team at Google. And over the next 45 minutes, together with two Google developer experts, Royi, Benyossef, and Etienne, Caron, we'll make you more aware of various challenges that developers have while building apps for billions. But rather than be talking about scalability or actual user acquisition, we'll take a step back, making sure our apps can, at least potentially, provide the proper user experience to a billion of users. We'll take into account huge diversity of users around the world, as well as topics like connectivity, device capabilities, data cost, battery consumption, and content. We'll be presenting you with tools and discussing real-life examples showcasing implementation best practices, as well as areas for improvements in highly visible apps from Google Play. I would also like to invite you to our Space in the Spaces app. Natalie, who is in my team, she will be interacting with you over there. So let's start. Probably every developer who creates a new product dreams about its worldwide adoption. Success is often defined by hundreds of thousands or millions of users. But what about billions? Is such a thing possible? Yes, it is. Just take a look on those randomly selected apps: Google Search, YouTube, Chrome, Maps, Gmail, and of course Android. Each of these Google products is used by over 1 billion of users worldwide. And what's probably quite important to many of you here in this room, when I mentioned Android, I didn't just mean the operating system. I meant actually over 1 billion of 30-day active users of Google Play. Luckily, all of those products serve as a platform for you to reach billions, your billions. So is it possible? Yes. Is it easy? No. Established markets are saturated with apps, while emerging markets have challenges that developers around the world are not always aware of. So even if your app went ultra-viral, or you spend massive amounts of budgets on promotion, chances are your app might not be providing them with the experience that would convert them into regular customers. Why? Well, did you realize that over half of the users in the world still might experience your app through a 2G connection? Or that data plans in some countries, they can cost upwards of 10% of the monthly income. Maybe you thought that most of the people on the internet actually speak English, while actually 74% of the online population does not. At Google, we are more and more aware of use cases like those just mentioned. Our mission is to make the world information universally accessible and useful. And while we believe that users have the same fundamental needs, keeping in touch with friends, being more productive at work, and so on, the environment in which they are coming online might be different. That's why we have launched various efforts internally and externally that aim at providing the best experience regardless of the user's connectivity issues, data plan limitations, or language they speak. One of the examples is offline mode for Google Maps. Now you can download all of area of the world to the phone, and the next time there is no connectivity like underground garage or the country road, maps will work seamlessly. Whereas before you could simply browse the maps offline, now you can get driving directions, turn-by-turn directions, and information about places like opening hours or ratings. Another example, in some countries, including Indonesia and India, we launched YouTube offline, when actually in the mobile app, when you are signed in, you are able to download some movies to watch offline later, up to 48 hours. Also, in India and Indonesia, we introduced lighter and streamlined search results and optimized web pages. On average, they load up to 4 times faster than the original ones, and they use 80% less data. As our users' overall experience became faster, we saw also 50% increase in traffic to those optimized pages. It's also very important that you can have a great experience online regardless of language the users speak. With Google Translate, we help more over the 500 million users every month to do translations in 103 languages. And we estimate that with these 103 languages, we are reaching 99% of the online population. So building for billions is a challenge, but we worked hard, we collected feedback, analyzed data, and learned a lot. Now we are sharing those insights with the broader developers community in the form of an easy-to-use checklist. You can find guidelines, recommendations, and best practices for both Android and the web at developers.google.com/billions. And remember, by adapting those best practices, you are not only opening your app for new users in emerging markets, but also providing much better user experience for those in established markets. So that was a glimpse of Google effort in the matter, but what about the developers out there? How do they deal with limited connectivity, varying device capabilities, data cost, battery consumption, and localization? To answer that question, I would like to invite on stage Royi Benyossef, who is a program manager at Samsung Innovation Center in Tel Aviv. And Etienne Caron, mobile developer lead at Shopify, based in Montreal. Thank you. They are both members of Google Developer Experts Program, which I'm very proud to lead globally. The Experts Program, thank you. The Experts Program is a global network of over 400 recognized and influential technology professionals experiencing Google technologies, as well as outstanding specialists in product strategy, marketing, and design. They distinguish themselves by frequently speaking at conferences, sharing their experience and passion by publishing videos, tutorials, writing code samples, mentoring developers and startups, and much more. Experts are verified by both Google and community, and they are acknowledged through a public directory. They benefit from easier access to Google product teams, are invited to exclusive events and projects like this one. And they participate in early access programs, trusted testers programs, and so on. Some have opportunity to indirectly shape the future of some of the Google products by participating in feedback sessions and customer advisory boards. Thanks to their support, developers, startups, and technology communities around the world create, build, and ship high-quality apps. So without further ado, I'm leaving you now with our top experts. Thank you.
Hello, everybody. So we're going to talk about connectivity. And as developers, we usually work in an ideal environment, right? The network is solid. We're going to test on somewhat recent devices that we bought locally. And truth be told, we often have a limited idea of who our actual end users are or what their day-to-day environment is really like. Typically, we're only going to come down from our ivory towers when we start getting reviews that look like this. And when these reviews start flying in, the damage is already done. So we're going to explore today how to engineer apps more suited to the real world. At a very high level, the approach breaks down as follows. So you're going to want to surface problems by simulating the real world as closely as possible. You're going to want to diagnose a problem by looking at its symptoms. And then we're going to talk about problem solving and prevention techniques. So let's start talking about actual connectivity. The real world obviously is a very complicated place. And in the real world, connectivity is an unreliable thing. So think about your users on a train, in the subway, or going up in an elevator. Is your app really always going to behave reliably? What about when 1 out of 3 server calls fails and times out? So let's find out. We need to see how our apps perform under stress. First, we're going to want to slow things down. Android emulators allow developers to simulate a various range of different network bandwidths, from full Wi-Fi all the way down to GSM. By writing a few functional tests and exercising those over a comprehensive range of emulator setups, we should be able to find out fairly quickly if our app misbehaves in certain situations and when network calls start timing out. The problem here is that we're still working in fairly ideal lab conditions. We don't just want a slow network, we need a flaky one. And that usually involves a debugging proxy, such as Charles, for example. This, Charles, allows you to limit the bandwidth and the reliability of your network connection. With this type of tool, you can control the round-trip latency, cause packet fragmentation, random connection failures, and just degrade the overall network quality however you see fit. After running our apps through those gauntlets, we now have data to work with, right? Likely we're going to have a nice list of issues to work on. We now need to investigate and find out what the root causes of these issues are. When investigating, we can start by taking a little peek at the Android Studio network monitoring overview. It gives us a nice idea of what actual communications are going on. This gives us hints, but obviously we're going to want more details very quickly. Again, a debugging proxy like Charles is very useful here. As mentioned, you can use it to inject flakiness in your network calls, but you can also see in detail what was sent over the wire, the timings involved, and if you have the right certificates configured on your device, you can start inspecting the actual SSL and encrypted packets that go through. Stetho is actually another very good tool, diagnostic tool. It will allow you, amongst other things, to analyze the network communications. You can see the exact timeline of requests, again, the size, completion time, all of this from within Chrome. One of the big advantages with Stetho is that you don't need to set up special certificates on your device and all that kind of extra work, since you're actually logging the information straight from the device. Stress testing reveals and surfaces potential problems and issues with our apps, and diagnostics gives us the information we need to get to the root cause and solve it. But ultimately, we'd like to harden our application and architecture it in such a way that we'll be able to handle whatever we get thrown at. So knowing that network connectivity is a transient thing, and whenever a feature of our application relies on that, we're going to need a strategy to gracefully degrade the performance and the feature set. The end goal is really to try to avoid surprising your users and to stay consistent. So let's see this concept at work with a real app. Make My Trip is an application that allows you to book flights, hotel, rail tickets, and holiday vacation packages. We can see an example here of how it handles connectivity loss when trying to book a flight. We get clear and concise messaging with a call to action to the users. That's nice. Here's a couple of other screens for Make My Trip. Again, we have nice, clear messaging with a cute cartoon character. So that hits all the right marks. There is the question of keeping your error messaging consistent, and that's actually fairly hard. To achieve consistent messaging, you need to take a step back and look at your app at a higher abstraction level from the get-go. So say we're going to work with a simple movie listing app with 3 basic use cases. We're going to have a list of movies, of nearby theaters, and we're going to be able to purchase tickets straight from our app. What can we still offer if we lose the network here? So let's apply a few of these ideas to our example. Right? We can definitely, using a cached copy of data, we can provide partial functionality for all the movie theater listings, obviously. Then we can prevent users from starting certain use cases, such as ticket purchasing. But what happens if we lose connectivity during a purchase? We could always kick the user out of the flow, but that's going to lead to lost sales and annoyed users, right? So let's try to find a way of gracefully degrading that. For the sake of the example again, let's imagine the simple ticket purchasing flow. Finding a number of tickets available for the selected movie showing is the first step. Then we're going to have a selection of the number of desired tickets to put a hold on them for, say, 5 minutes. Then the user is going to complete the purchase. If we take the first of these flows and focus on it, this is an example, is the golden path, right? But obviously we're going to need to handle errors here. So we're going to want to be able to say, try again later if an error comes up. But that's still pretty irritating if the network is kind of flaky around our area. Chances are high the users are just going to give up on the purchase, right? So you can make the flow more solid by simply retrying the server calls when possible. You're going to want to be smart about retries. Consider using exponential backoff logic in the right places. I definitely encourage people here to explore something called RxJava, a fairly popular library, to solve that kind of problem. When a request, for example, finally does time out or fail after, say, 10 attempts, like on this diagram, consider giving control back to the users by giving them a try again or a give up dialog of some sort. Or if you're clever about saving transaction state, what you could do is give a users a way to complete the purchase at a later time. That saves the user a lot of work, and offering a way to complete the transaction later when the network comes back up, people are going to appreciate that. So very simple example, obviously, but the key concepts are as follows. think about the big picture to avoid surprising your users. Be consistent in when you surface connectivity errors. Try to say the same messaging all over the app. Keep the same messaging all over the app. And when an error does actually occur, try to save your users work and allow them to complete any given flow later if possible. Let's look at another offline example. Practo is an app that brings health and fitness to your phone. You can use it to save and share your health records or book a doctor's appointment, find a clinic, things like that. Practo, in this case, partially supports finding a local clinic even if you're offline. So that's actually great value for end users, right? Especially when you're looking for a consult. If you don't have the network, you still need a doctor. That's actually pretty awesome. Don't hesitate to be aggressive with the offline caching of your data. Even if it's not the freshest, it can provide really great value for your users when connectivity is hard to come by for a relatively low development cost. Ultimately, connectivity is still the game changer. So consider that if the internet is not available, it's not the end of networking at all. Modern mobile devices give us a ton of multiple connectivity stacks. So you could use Wi-Fi Direct to create an ad hoc mesh network, or you can use Bluetooth to share files between devices. So if your transactional and domain logic supports it, you'll be able to bring great value to users, even if you measure network latency in days instead of milliseconds. In the same vein, don't disregard MMS and SMS. In remote areas, even slow network can be lifesavers. For years, nurses in remote locations where doctors were not available have been sending photos of actual wounds to doctors for a prognosis. So then, that provides awesome value even though people are really remote and you don't have a fancy network around. So the better we get to know our users and the infrastructure available to them, the better we can serve them. Hotel OGA is a hotel booking management app and is a great example of using an alternative networking solution. They developed a strategic partnership with African multinational telecommunications companies, and this allowed them to provide dedicated data-only SIMs to their users. Their app also works offline and supports SMS as a fallback communication mechanism. So now I'm going to hand it off to Royi.
Don't worry, he's coming back. Hi. Hello, everybody. Okay, so after we discuss connectivity, let's discuss the cost of it. All applications, modern applications, require connectivity, and connectivity costs money. At least when you're on a metered network like LTE or 3G or anything that you need to buy a data plan for. Let's consider the data plan like a battery, only you charge it with your wallet instead of your wall socket. Now, there's no real analytics about how much is too much, but there are pain points to notice and patterns to notice as well. So app size is important. It makes a difference. Why? Because if you see an application that it's 50 megabyte and you're on 2G and it costs 10% of your yearly paycheck, it is most likely you will not download that on 3G. You'll wait for Wi-Fi. Same goes for updates. People will delay updates if they think it's too big, and they might not get the updates. And we all know as developers, updates are important. So let's start with dieting, code trimming, third-party libraries to be exact, borrowed code. Most of us take these libraries which are very big, and we only use like 10% of them. So the smart thing to do is to carve out what you're actually using, which is a good pattern altogether, because then you'll know what you're relying on. And it also helps to reduce the amount of code. Code duplicates as well is a big problem. So use lint to find the code duplicates and refactor them, and you'll save 90% of that. Moving on to something a little bit more fattening, which are images, and it's also a lot easier to maintain them. For instance, use lint to find all the unused images in your applications. You would not believe the amount of data you'll save there, the amount of space. Also, take your PNG and JPEG files and put them through online compressing and optimization engines. Most of the size of your JPEGs and PNG files are metadata that the user cannot see, like where was the picture taken or who took the picture. If you reduce that, you might reduce up to 90% of the image size. So do that. You can also go ahead and use more progressive formats, such as vector drawables or 9 patches, or you can either eliminate resources altogether by tinting, which is taking a list of icons and then coloring them in various colors, or using the dynamic resource content coloring, which is the palette API. If you're not familiar with these concepts, then where were you in the last 2.5 years? Last but not least, you can compress. Just use the, can't remember the name, ProGuard, which is also cyber secure, but also compresses the size. So we got the diet all figured out. Let's go to day-to-day usage. Network usage has one golden rule, which is the same as in all dieting. Simply think about everything you're putting into your mouth. Downloading, sorry. Never download anything twice. If you're polling and just taking down information, it is most likely you're downloading something more than once, and that's wrong. There are many patterns that you can use that help you know exactly what changed and when it changed, like GCM downward messaging, or like staleness headers in the server side, or diffs in the server side, etc. So use them in order to never download it twice. Be conscious of network type. For instance, if you're on a Wi-Fi, since we're discussing price here, if you're on a Wi-Fi, download everything, cache everything, and there on 3G, be much cheaper with your data and only download what the user has asked for and what they can see. That just makes perfect sense. And you have handlers inside Android to give you pretty much all of it. Optimize backend. Backend has a lot of power here. Most backend programmers are like programmers, which means they're lazy. Simply tell them how much it would benefit if you would change the API to fit only what the user sees at any given time and how much it saves in radio time. And I can guarantee they will not listen and you have to go to their bosses, but still, you'll make a good argument. And if we're talking about backend, let's also try and use new and exciting stuff like flat buffers, or like GCM, or like diffs, or like staleness headers. They'd like playing with that because you like playing with new stuff, so they should like it as well. And you'll save not only battery and data costs, you'll also save time performance. Facebook and Google with flat buffers have reduced time with loading their own apps for up to 90%. So not even data cost. Now let's go to something a little bit different, which is battery consumption. It's almost exactly the same with a key difference. The cost here is implicit. You cannot, it's not money coming out of your pocket, but it does have a cost, and let me show you how. I'm in my office, 9 a.m., putting the phone in my pocket, and I'm working on emails or whatever it is that I do. At 11 o'clock, I check my phone to see if I have any calls or messages, and I see two sad things. One of which, I got no messages and no calls because I have no friends. And the second thing is that I lost 37% of battery. That's an actual case, by the way. So there's a problem here. Battery is life for most people. People live on their phones. So you have to be conscientious of that. Now, let's talk about the tools that will help you as good Android developers, help me as the user avoid these kind of situations. So first of all, best example out there is the Battery Historian. It's not that new anymore, and it's very helpful. It tells you exactly what portion of your application, service, thread, activity used what energy non-efficient hardware device, like the GPU or the CPU or the kernel or the job schedule or whatever. Let's take an example. This is the application known as Make My Trip, which Etienne already introduced you to. And you can see the amount of data that's applied to you. You know if the device was rebooted. You know how much time the CPU was running. If you have Wi-Fi, how much time did you scan? What's the signal strength? Temperature, which I have no idea why, but I'm guessing Ran can explain, etc., etc., etc. There's a lot of data here that you can use in order to help you know what's going on. And just give a quick round of applause for this amazing 1/8 of 1% result for a full nighter. Make My Trip. I don't know if you're here, but kudos. Okay, you can actually applaud if you want to. Second thing does not really involve around you, but what you need to be aware of. Those in standby, and if you don't know what that is, please get up, go outside. But there are tools that were implemented in Lollipop that are helping the device solve itself from you. And you need to comply to it in order to be graceful and to work with it. The tests are fairly easy. You simply plug in the device, turn on your application, turn the screen off, and then plug in these bash commands, which are pretty straightforward. Then you turn the screen on. Okay, it's not that simple, okay? But they're simple commands. It's just a lot to remember. And then you see an example. This is Rounds. Rounds is a beautifully made video calls application that has handled, this is a real test we did in animated GIF, handled it, well, beautifully. It's, and again, round of applause for Rounds because I see their CTO right here, and he's gonna, okay? Same thing goes for DOS. That was standby, this is DOS. Almost the same test, only different bash command. Same result, they did their job just right. It's possible, it's plausible. Okay, moving on. Radio. Radio is the thing that you use in order to access the internet, so you need to be careful with it because it drinks a lot of juice. Sorry, that's why I'm with the speaker. So it comes to a saying that I like to say, which nobody understands, but I'm on stage, so you have to hear it. Let sleeping radios lie. What do I mean? These are the practices that you need to use in order to save your radio and your battery. So the first thing is use batch calls, meaning that you can use either Job Scheduler, which was introduced in Android 6.0, or GCM Network Manager, which is exactly the same thing, only backward compatible for all apps that have Google Play services from version, I have no idea, Google it. Or Sync Adapter, which does exactly the same thing all the way back, but it's a little bit too complex. It's not too complex, a little bit more complex to implement. So if you do not have access to these devices, use Sync Adapter. It's plausible again. And it will batch the calls together so you would not call the radio all the time, only in specific maintenance windows, which saves battery. Never download anything twice, returning back. You remember we talked about it in data cost? So again, same thing, progressive server client scheme, changing the API, using downward GCM data, or using GCM to update what's changed if it's small enough. All of them are viable examples, but the most important thing is stop polling. Polling is the worst thing you can do in an application. And there are so many patterns you can use, so just please, for me, for you, no I don't, for the children, I'm just kidding. Okay, so after we optimize the actual request and the back-end side and everything else, let's just listen to the users. You have enough handlers and listeners telling you if the user actually wants your data right now. So if the screen is off, it is most likely that the user just doesn't care. If it's plugged into the electricity, you can do whatever you want to because the battery will never run out. But if it's not, and you know the battery level and it's low, and you're the difference between a brick and a working phone, don't update. You have activity recognition, which is wonderful because it's not only telling you if the user is present or not, it tells you context. Because if you're a traffic app, it makes perfect sense to update more while on the go, but it doesn't make any sense to update news scores while someone is driving. So context is key here, and it gives you a lot of information. Okay, now I'm handing over the clicker again for device capabilities. Please welcome.
All right, so let's talk about device capabilities. Android runs on a multitude of different devices. That's no surprise to anyone here. There's different OS versions, screen densities, processing power, memory, storage. All that stuff can be very different from one device to the next. So when going global, your user's device will likely be very different from one instance to the next. You're going to need to have your apps optimized and flexible and ready to handle all these different use cases. So another thing to consider, about 5 of the 7 billion people on Earth do not understand English. Localizing an app can be very challenging, especially if you didn't plan for it. So think of the different character sets of right-to-left languages, and strings, once translated, can end up 50% longer, especially with French and German. So once translated, your carefully designed UI could very likely break. So what can we do to catch issues before we release? Well, emulators allow us again to configure various screen sizes, change the disk size, change the memory configuration, and the locale settings. So all of this is great for testing your UX. But no emulator covers all the different hardware configurations that you're probably going to see. Think about the different hardware and the software drivers, right? Or x86 versus ARM, OpenGL3. Those things are usually not available in emulators. They can't tell us with 100% accuracy how our app will actually perform on the real hardware. So ideally, you're going to want to test your app on real devices. One approach is to build your own hardware test lab. That's usually fairly expensive and time-consuming when you think about maintaining those devices, making sure they're up, handling the random crashes, and etc., right? So consider using a testing lab service such as, for example, Google's Cloud Test Labs. Between emulators and devices testing labs, we are now close to real-world conditions. So we're ready to test and start hunting for issues. For UI and UX testing, it's challenging to completely automate the process. How do you write a test that validates if a screen is actually legible or really usable, or that the translated UIs actually still make sense? That's where human intervention is most likely needed. You might be thinking, wait, if I multiply screen densities by orientation and then again by the number of locales I'm going to support, yeah, that is a lot of screens. So, but if you have the proper UX integration tests and that you exercise most of your UI, you can actually take screenshots of those UIs as you go on the different devices that you're testing on, and you provide those to your QA. If you run a diff tools on these images, once somebody has validated an image, you only need to look it over again once it actually changes and you detect a delta. That makes things a lot more manageable. Benchmarks can allow you to monitor performance execution time of your hat. So even if you can't run them off of the physical device, by keeping the actual benchmark historical data, you can raise alarms when runtimes change significantly from one version to the next. Of course, this means you're going to need to keep that history in the first place. An actual easy way to do this is to use your favorite metrics or analytics tool platform. Using that data then, you can write all those tests, create alarms, or even fail the test if the numbers are starting to look bad. It's worth noting here on the slide you see that there's a dumpsys gfx info ADB command in there. That one's very valuable when you want to sort of monitor the actual performance of the rendering of the app. So given the range of screen sizes your app is going to be running on, your layouts will be anything but static. And that's really nothing new, right? Web designers have been dealing with this forever. So consider exploring all that great literature on responsive web design and draw inspiration from it. Think of Bruce Lee, basically. Your layouts and content needs to be like water. And also don't feel forced to write one layout to rule them all. Don't forget you have all these local specific classifiers that we see here on the slide that you can use to create exceptions to handle those corner cases. You can do stuff that, you can change the layout for certain languages which are just taking up too much space, or accommodate the different widths of screen, etc. Right? And here are some of the most important strategies to follow when you want to do responsive layouts and responsive design. So alternate your layouts, try to reuse your view groups and fragments, localize the layouts when necessary, think about left to right, that might change some of those layouts pretty drastically. Material design metrics and key lines are really a nice tool to be aware of here when you want to do responsive design. Use relative, percent layouts, DPs and SPs for text. Never use PX, please. It's for your own good. 9 patches are nice, and SVGs and vector drawables are a very nice tool as well when you want to do responsive. For memory, I'm going to keep it short. Simply avoid the big pitfalls. Image loading is a scary place, usually, and leaking context is typically the one that everybody gets wrong. So keeping an eye on all that memory is very important. So consider using a tool like Leak Canary to detect the leaks early and keep things simple for you, right? Then there's localization. We've touched on it. So this is a well-known quote by a French-Canadian philosopher, which roughly translates to the following. You notice it's actually longer in English than it was in French in this case. But anyway, proper localization is actually super hard. And this is one of the areas you're going to need to apply some tender loving care if you really want to reach a wider audience. So these are the big challenges right here. We've talked about the string length variance. Think about things like numbers, dates, and time formatting that will change depending on your locale. So will your currencies. You might have currencies that are going to be used in different locales as well. You're going to have different rounding rules depending on the countries. So remember that locales are a language and country. And think of localization QA and think about it early in the process. You want to catch that time where the translators are actually sending you machine translations instead of human translations and charging you for it. How will you know if you don't speak Japanese, for example, right? So you need to think about all those QA factors. They're very important. So we're going to pass over to Royi again. Thanks.
Hear it for Etienne. Okay. So I know we've dropped a lot of information on you, and we're running low on time. But this is the last segment, and it's probably the most important because it's the one that's being left behind most of the time. So, how do we diagnose content? It sounds almost irrational. Okay, Android was kind enough to have a lot of tools into groups. on-device or hosted devices. Now, because we don't have a lot of time, I'm going to do it real quickly. So if there's a tool that you don't know about, tough for you because most of them have been around for 5 years or longer. So let's start with strict mode. Strict mode simply does a border on the skin of an application if you're doing too much work on the UI thread. Simple as that. If we look at an example with this Gojek, which is a location-based services application out of Indonesia, and it's a beautiful application, you can see it's completely compliant because you see absolutely no red border, and trust me, strict mode is on. So kudos, guys, if you're here. Profile GPU rendering. It means that it tells you how long it takes to render each frames in 4 paths, which are creating display lists, syncing the render thread, issuing the display list, and swapping the buffers. And if it means nothing to you, go talk to Ron. I don't know. Here's an example with Myntra that we talked about before. Beautiful material design. I'm going to say it a few times. I love the app. It's an e-commerce app. The problem is that you see the graph below, and it's most of the time it's over the threshold, and then you see peaks where it janks. That's exactly what's wrong with it. Just imagine how this wonderful looking app would look better if it was completely performant. Debug GPU overdraw is very important because it's telling you how many times you draw each pixels, which tells you what is the GPU overhead. Well, you cannot avoid overdraw, but lower is better. So make my trip, which we did mention before, again, looks great. And as you can see, first of all, in settings, it's not transparent. It's a good thing to show. Make my trip is almost transparent, and it does so wonderfully. But the navigation drawer is almost completely red. And I hope it's because they used the wrong third-party library. So guys, check this out. The funny thing is this one. Look at the scrolling. It will scroll down, and you'll see that the images become redder as they go. This just screams get view issues. And it's a perfect example of how you can find performance issues in get views which are completely implicit to the tools. So guys, check it out. Otherwise, this app is just beautiful. Host tools, layout and hierarchy. Hierarchy viewer. Is there anybody who doesn't know hierarchy viewer? Excellent. Moving on. Now, GoRide, which we mentioned earlier, is a wonderful example. I love this app. It's beautiful, it's clear, but in this screen, they have 14 layers, which means that on my device, which was powerful and modern, everything was great. But if you think of a lower-end device or an older device, it might jank as hell. So I would check that. Method and event profiling has systrace, which is putting the events in the system in a timeline, and it's very, very helpful. It also has trace view, which has trace mode, which traces the method calls, or it can check out through a limited time, which is something it's called sample mode. I'm examining Practo, with systrace because it looks smooth enough on my device, but you can see all that information. You can also see the frames. Notice that the frames are right on the place where they paint it. So systrace actually said that one of these frames was delayed due to the fact that it used too much UI thread blocking over other threads, and it had a problem with background thread priorities, so it was delayed and caused jank. This is perfect. It actually tells you what you're doing wrong and how to fix it. Allocation and memory profiles are very important because allocations are very important. Now you have 3 main tools. You have the allocation tracker, which is best if you have jank in specific animations and you don't know how to solve it. It will tell you exactly what to do. You have MAT that helps you find memory leaks. And you have memory monitor, which puts a visual representation of heap usage, and it's very helpful for runtime. This is an example, again, for Make My Trip. Wonderful example. We don't have time to go into it, but trust me, it tells you a lot. So let's talk about pain point. If you have problem with UI responsiveness, pay attention to your allocations. Use the memory allocation tracker, because if you're allocating too much, you're just stopping the CPU and GPU. UI should not be dependent on loading. Decouple rendering from connectivity is important. Use caching for this. Use all kinds of pattern for this. Simply put them apart. It does not need to impact one another. Use the GPU correctly. If you do not know if you're using the GPU correctly, that's wonderful. Use the rendering agent and the overdraw to know if you're using it correctly and you're using hardware acceleration correctly. Moving on to UX. UX is even more important. Your app could be absolutely performant, but still terrible. So here are a few patterns to help you not be terrible. Material design is a good place to start. It alleviates a lot of aches. You really need to know what you're doing if you're stepping out of material design, and I cannot stress this enough. Cover oral end and empty cases. If there's a reason that you do not have content on your screen, it has to be apparent as to why, with a clear message, and preferably a nice animation to make the people feel better, a call to action so that they'll know what to do, and a way to do it on screen. So for instance, GoJack, again, now they're right. I had no items in progress or completed. They're absolutely right. But to put a blank screen tells me nothing. It's just kind of disappointing. On the other hand, rounds have a wonderful screen telling me that I don't have any chats yet. It's nice and colorful. It has a button for me to start a new chat, and they're giving me a call to action. Wait for it, start new chat. I actually know what's going on and what I need to do, and that's perfect. This example I don't have time for because Etienne already mentioned it, so we're moving on to avoiding deprecated patterns. I see a lot of applications that I'm reviewing that are using the overflow menu, the dashboard pattern, the action bar. They're old. We stopped using them because users don't like them, because they're cumbersome, because they're dated. Stop using them. You have plenty of new things to go. Practo, again, is a wonderful application. Almost everything is elegant and correct, but they're using the overflow menu on my phone. It has Android N. It's not even M. And it looks dated. It's only text. While Make My Trip, look at how colorful and wonderful that is. I think it speaks volumes. Last but not least, and I'm not going to give an example because I don't have time, is find out the places that has a lot of friction. Smooth them out by understanding the users and putting something that makes them understand what's going on. So now I'm calling Dawid again to wrap things up and mention other stuff.
Thank you, Roy. Thank you, Roy. That's all that we have prepared for you today. I hope you now are much more interested in topics that affect users around the world: connectivity, data cost, battery consumption, device capabilities, and content. If you would like to learn even more, please attend other sessions on building apps for billions. The one focused on the web will be tomorrow at 10 a.m., followed by the Android one at 3 p.m. Please don't forget to go to developers.google.com/billions to make yourself familiar with the details and recommendations and best practices. If you would like to learn more about Google Developer Experts program, just go to developers.google.com/experts. Thanks a lot for listening and have a great evening. Thank you, Roy and Etienne. Thanks a lot.